Yep. I started that test, but I don't know. I got kind of confused. A couple of them were pretty easy. I don't even know if I got them wrong. I just thought.
How many did you
I
end up doing?
watched. I think like 5.
And it's a test, yeah.
But it's the pre-test, not an actual test.
Okay, is it the multiples one, the primes and multiples?
Yeah, because primes and multiples. Yeah.
All right, let's see
I
it.
watched this video, and there was a. I mean, the lady made it look pretty simple. All you have to do is like multiply, right? But then I don't know. They get you with those questions.
Yeah, the whole idea is that like a multiple of something is just the number that you get after you multiply by something, and a factor is something that you get when you divide a number by something. And then it also all has to go in evenly. But since it's a pretest, let's see what it is. We'll just try it. You there? It stopped sharing.
Oh, okay.
Which
So
one?
this one would only be. It would only be once. Yeah, because I was kind of confused, So I got a few of these, but it would only be 16, 32, 48, and 64, right?
Yeah. Okay. So multiples are always like equal to or bigger than the actual number. So like multiples of 16, you can't get smaller than 16.
Oh, okay, cool. Yeah, because I did some research on one of them just to see, and that's what I read. It wasn't. It didn't really. I didn't watch the full video, but I could see that it was like multiples, and then he kept doing 18. Then it was 36, and then
yeah,
so
like
okay,
on your calculator right now, do like it's 16 times 1 should give you, I mean that'll give you 16. 16 times 2, I think that'll give you 32. Yeah? I'm going to do it.
Yeah.
So
16 times 3 would be 48.
Yeah, so it's like all of the whole numbers times the original number. So 16 is the original number. All the whole numbers times that, whatever you get, those are the multiples of 16. So like the lowest that you can start out with is 16 in this case.
Okay.
And it's just the next multiple of 16 is 2 times 16. The next multiple after that is 3 times 16, whatever that is. And then the next one is 4 times 16, and then it keeps going and going and going forever.
Cool. All right, so hopefully I got these right. Freaking.
Yeah, if not, what happens actually?
It
just assigns you the course, right?
I got another course, so we can just start on that one. Then.
Oh, okay. What is the greatest common factor of 6 and 8? Okay, so this is talking about factors.
And factor is a number that you can multiply, right?
The greatest common factor is which is the biggest number that goes into both of them. Like because factors are like dividing, multiples are multiplying. Factors like Actually, this is a thing. Let's see this. What are the factors of 6? Like what are you allowed to divide 6 by and get an even number?
2 and 3, right?
2 and 3, and then also 1, but we don't have to care about 1. So 2 and 3. What numbers can you divide 8 by?
2 and 4.
2 and 4. So the greatest common factor. It's like, so for 6, the factors are 2 and 3. For 8, the factors are 2 and 4. The greatest common one, the one that's in common between those two, is 2. Right? So that's it.
Oh, okay.
Like sometimes they have multiple common factors, and the greatest common one would just be the biggest number. But
okay.
Yeah, you got to think of like, what do you? So a factor is like, what are you allowed to divide by, and you get a whole number. That's what a factor is. Okay. So you just do that for both of them, and then the greatest common one is the biggest one that's shared between the two.
For both.
Cool. The work that Yi did to find the greatest common factor of 42 and 63 is shown below. So, okay, so he wrote down, or she, or whatever, wrote down the factors of 42. So, like 42 could be divided by 1, it could be divided by 2, 3, 6, 7, and all those numbers. And then same with 63. The greatest common factor is 7. What is Yi's error? Okay.
And this is where he does the little triangle going down, right? Or the way you write it out.
Yeah.
So it starts at 42.
Let me do that too.
So on the 63, I would say he didn't list all of them, right?
Well, the greatest common factor. Maybe he didn't list all the factors. Like, what about 63? Yeah. Can you do what is your thing?
There'd be 2, or they wouldn't. You can't divide it by 2, right?
No, because it's odd. So.
What about 3? Let me see if I can.
Yeah, let me see. So 3.
Yeah, so 3 times 21 would be 63. So.
Yeah, so 21. That's a key. You're allowed to divide by 21 for the 63, right?
Yeah.
You're also, like, you can divide 42 by 21. So 21 should be in that 63 list. 21 should be there as well. And like the way to actually, I guess, do it is to go like, what am I allowed to divide 63 by? I can do 1. I can't do 2. I could do 3, and that gives me 21, which is a whole number. That's how I know I'm allowed to divide by 3. But also, that means I can divide by 21, because then I'll get 3, which is also a whole number. So 3 and 21 should be on that list for 63. But they just didn't do the division to see that. So
you did not list all the factors of 63.
Yeah, for sure not, because 3 and 21 aren't on the list, and those are both factors. Those are both things that you're allowed to divide by and get a whole number. All right, let's see. Mika found the least common multiple is different from greatest common factor. That's like two things that are kind of confusing, because I don't know, when they're taught at the same time.
Yeah.
But multiple is like what you get after you multiply like a number by something. You start with whatever number and then multiply by 1, multiply by 2, multiply by 3, and you do that to say the same thing on the other number, and then the smallest number that matches between the two lists is the least common multiple. So multiples of 8. So the first number is 8, which is 8 times 1.
How could it be 12 though, you know?
Right. So 8 times 1 is 8. 8 times 2 is 16. 12 shouldn't be on that top list.
Yeah, or even 20, right?
Right, because there's no whole number that you can multiply by 8 to get 12, and there's no whole number that you can multiply by 8 to get 20. So those shouldn't be on that list at all. Because it should be, if you're going to list out the multiples, it should be like, okay, if you're doing the multiples of 8, it should be 8 times 1, 8. 8 times 2, the next number should be 16. 8 times 3, the next number should be 24. 8 times 4, the next number should be 32. So they're adding extra numbers in there because they made a mistake. So,
okay.
Mika listed some values that were not multiples. That's true because 12 was not a multiple, and 20 was not a multiple, and 28 was not a multiple. Mika listed factors of each number instead of multiples. Factors would be smaller than the number. So
that's wrong.
Yeah, that's wrong. Mika should have multiplied 8 and 12 to find the least common. That doesn't always find you the least common multiple, so number 3 is wrong. Multiplying 8 and 12 together finds you a common multiple, but not the least common multiple every single time. Mika selected a multiple that is not the least common multiple. It's the first one. Because 12 and 20 and 28 aren't multiples of 8. All right, let's see. All right.
Well, we passed.
So one of the big things is that factors are like a factor of 22. All of those numbers that are factors are going to be smaller than 22. Multiples of 22 are going to be 22 and bigger. They're going to be larger. So like multiples, you start out by multiplying by 1. So the first multiple of 22 is 22. The second multiple of 22 is just 22 times 2, which is 44. And then the third is just times 3, whatever that is, and then so on. So
and then the multiples are bigger. The multiples begin with the number and then
go bigger. Forward. Yeah. And then factors are always smaller, and it's whatever can divide that number evenly.
Cool.
So what's the next thing?
I don't know what I'm about to see right now. Let me lift this screen.
Yeah.
Powers and exponents.
Okay, so we talked about that a little bit. Powers and exponents. Yeah, let me say one thing for like 2 minutes, and then we can try it. It's the same thing as before, but it might, I don't think it's going to jump into fractions or anything.
Something crazy.
Yeah. Powers and exponents. So what we said before was like if you have 3 to the 4, that doesn't mean, so that means not equal, that doesn't mean 3 times 4.
4, right?
Yeah, that's not right. It's 3, 3, 3, 3, 4 times. And so that would be 3 times 3 is 9, times 3 is 27, 27 times 3 is 81, I think. So this, like 3 to the 4th means multiply it 4 times, or use it 4 times in the multiplication, but it's also times itself. I can't imagine they would go into more than that, but if they did, if you had... Actually, no, let's just leave it there, and we'll see what they have.
All right.
Because there's a bunch of rules with exponents, but I'm not sure they'll get to it all at once. Powers and exponents.
It'll probably be this whole course. So
yeah,
because this one's pretty. We're still at the beginning of it.
All right. Oh, okay. So there was a teacher that I had that said that exponents. So actually, just from any terminology that you know, which one is the exponent here? The 2, the 5, or the 4?
The exponent meaning I would say it was the 2, right? But
so the 2, it's in front of everything and it's like written bigger. That's the coefficient. The 4
okay.
is the exponent. And the parentheses. So like the 5 and the 4, they're connected together just like I wrote down the 3 and the 4.
Yeah.
It doesn't mean so like the 5 and the 4. Actually, can I share real quick?
Yeah.
It'd be easier for that. Because this is based on notation. So we have 2 and then 5 to the 4th. The 4 is the exponent. 5 is actually, it's called the base. And then the 2 is just called the coefficient just because it's out in front and it's multiplying in the front after you do everything else.
All right.
But before I was saying 3 to the 4th, that means you use 3 with multiplication 4 times. The same thing happens here, only with the 5. So the 2 actually just hangs out. Nothing happens to it. But the
4
5...
right now, right?
Yeah, the 5 happens 4 times.
Okay.
So you do you do the exponent with the base. You do that first, and then whatever's being multiplied afterwards, which is the 2, you do that at the very end. So I don't know, is there an answer that says this? 2 times 5 times 5 times 5? Like even without parentheses. 2 times 5.
It's a 2, 4, yeah. Yeah, that's the second one.
That's the same. So like once it's all multiplication, you don't need the parentheses anymore.
Okay.
The parentheses are just to let you know that you're writing the 5 4 times. You're not writing, so that like this is the distinction. This is not right. If you did this 4 times.
Yeah.
Because
so the answer would be like if it was 5 times 5 would be 25 times, so 25 times 5.
Yeah.
After that.
So.
And then whatever you get, let's see, 25 times 5.
125 times 1 more 5. So 625. And then times the 2 out in front times 2.
Yeah, and you get 1250.
Yeah. Right. So that's what this would end up being.
Okay.
That's probably the easiest way to like figure out if you're doing it right or not. Like if you wrote this out and then multiplied 2 times 5 times 2 times 5 times, you wouldn't get the same number as this. It'd be different.
All right.
So the parentheses are to let you know that the 4 is only saying write the 5 4 times. And then the 2 just continues on until the very end and you just multiply by 2.
Cool.
Right.
What is the base of the expression? So it'd be the 11, right?
Yeah. Yep. And then the 12 is called the what?
It's the exponent.
Yep. They did do that. Okay.
We still got time if you want to write it out and look at it.
Yeah, Jim's work evaluation. Are you evaluating that? Is shown below. Can you scroll down?
Yeah.
So the answer is the second one, but I want you to save it so that like I can save it and exit so we don't waste time. I mean, I don't know if we'll need time, but just to be...
Yeah, just to be on the safe side.
All right, so this is exponents with fractions. There are different rules that you use with fractions. So they had 3 over 5. I don't think it was, I think it was to the third. And then they had 2 out in front. So the 2, just like before, you leave the 2 to the very end. It just stays there the entire time. You wait to the very end. The first thing that you evaluate, the first thing that you work on is the exponent with whatever's inside the parentheses. So if we were to ignore that 2, say the 2 is just out there, we're going to ignore that for a little bit. This part, 3 to the 5th, that fraction, we could change it into a decimal and then multiply it by itself 3 times. But then it'd still be hard to answer this question. So the way that I'm going to write it out is just by understanding that this 3 means write this fraction 3 times in a row and multiply. So I'll have 3 over 5 times 3 over 5 times 3 over 5. This 3 has been taken care of because I have 1, 2, 3 of those fractions, and I mean, this is what I wrote down 3 times. So that's what that means. So when you're multiplying, all you have to do is multiply straight across the top for fractions and then straight across the bottom for fractions. So this is actually the same thing as 3 times 3 times 3 over 5 times 5 times 5. And we still haven't done anything with this 2, so that would carry along. That would be still times 2 out there. Still times 2. I don't think in the problem they did the bottom part. And there's a shortcut to remember, but can you see in the steps, they didn't write this part, right? Hello?
I don't know why.
Okay. So what part did it cut out on?
Oh, it cut out as soon as we went to your screen. I couldn't hear you, and I was sitting there, and then it said no internet connection.
Okay. So I think what it was this, something like this.
Mm-hmm.
Like we know that this 3 means write down, so that's the exponent, write down the base, which is the 3 over 5, write down that base 3 times, and then multiply. And then leave this 2 just like we did before. The 2 just stays out in front until the very end. So that's what we're going to do here. I'll just leave that 2 out in front. And then I'll have the 3 over 5 times 3 over 5 times 3 over 5. I've taken care of this 3 because I wrote it 3 times, 1, 2, 3, and then I multiplied because that's what this means. And then the rule for multiplying fractions is that you just multiply straight across the top.
Oh, okay.
And then straight across the bottom. Mm-hmm. So like even without evaluating it, with just writing it down, you could write 3 times 3 times 3, but you have to do the same thing on the bottom, so that'd be 5 times 5 times 5, and I don't think they did that part. I don't think they did the denominator part. And I think that's one of the answers.
How would you break down the whole question itself? Like, I mean, the answer. So once you do 3 times 3 would be 9, and then 27 would be up top, right?
Yeah. And then the bottom, you still have to do that. So 5 times 5 would be 25.
Times 5 is 125.
125. And then there's a 2 out in front. This, if you wanted to keep going, I would put the 2 over the 1, because you can always put a whole number over 1 and then still multiply straight across the top, straight across the bottom. And so 2 times 27, that would be 40, 54.
54.
And then 125. And then I don't know, like I would try, like you could try to reduce this fraction by dividing by like 3 or 4. Let's try to divide by 3. 54 divided by 3 is 18. 125 divided by 3 doesn't work. I don't know if that reduces. Like you keep trying numbers, but
yeah,
that would be,
should be the final.
The fraction, yeah, that they might. Like if you could reduce, then maybe we divide by 4, divide by 5, well, divide by 6, and see like if we could reduce it. But this is the actual fraction that he should have came up with, but he didn't do the denominator part. Here's the thing. There's a shortcut. And I think they're probably talking about the shortcut, which is if you have a fraction with an exponent, so here's the fraction as the base, it has the exponent of 3. The way that you can think of it as is like the 3 goes to the top and the 3 goes to the bottom. So it's the same thing as 2 and then 3 raised to the 3rd power over 5 raised to the 3rd power.
Okay.
And in that case, it would just be 2, and then this part means 3 times 3 times 3, and this part means 5 times 5 times 5. So it's the same exact thing.
Yeah.
It's just a lot of the time you think of that shortcut where you just put the 3 on this one and you put it on that one. I don't know. That's what he didn't do. He did it to the top part. He just didn't do it to the bottom part. For the answers, he didn't do it with the denominator.
Nice. These ones, like, I guess it's not that. I guess I don't know. We'll see.
There's a lot of rules. I feel like that they're
sure it's gonna be harder
introducing all at once. I feel like that's what the thing is going to be. All right, which expression is equivalent? Okay.
So I would do the A, I guess, right?
Yeah. So when there's no parentheses, it just means, so you see the exponent is 9, and it's closest to the q, right?
Yeah.
When there's no parentheses, that means the exponent is only for the thing that it's closest to. And so that means, yeah, it's only for the q. It doesn't apply to the p at all. So p, just like in the top, there's only one p. Same as in that answer. There's only one p. The third answer, that one, when it has parentheses around it, it means the 9 is for both the p and the q. So if you were to write out the third answer, it would be PQ times PQ times PQ times PQ, a total of 9 times. So it's just something to...
But there would have to be a number outside the parentheses, right?
Right. Um, it's just whenever it's written like in A, if there are no parentheses, then the 9 is only for the thing that it's closest to. If there are parentheses, then it's for whatever's inside the parentheses. Jerry believed the answer to one of her homework problems was 2 to the third. After checking her work, she realized the correct answer was 2 to the ninth. How do these two answers compare?
The correct answer is 64 times Jerry's answer. So what are they trying to say here? Jerry believed the answer to one of her homework problems was 2 to the third.
Hey, do you know how to type that into your calculator?
Like the 2 to the ninth or 2 to the third? Or what?
Yeah, but either of those.
No, I haven't tried it.
Okay, let me share and show you. Because it's asking, like, what... well, we'll see when I do it. Okay. So to do 2 to the third, you can hit 2. So the 2 button, and then on the left side, underneath the M plus, it's the XY button.
Yeah.
So it's like 2 raised to the what, and then you do 3. And then equals, and that would be 8. Because 2 to the third, let me just write it out. Oops.
How'd you make it go to 8 though? If you did it.
Yeah. So like first 2 to the third, that's the same thing as 2 times 2 times 2, and then 2 times 2 is 4 times 2 is 8. So that's what that equals. But to do it on the calculator, you do 2, and then I call this the exponent button. So x to the y. So 2 to the, and then hit the 3, and then equals. And it'll give you 8.
Oh, okay.
So then, like, try 2 to the 5th. What do you get for that? And then I'll do it on my screen.
32.
So 2 raised to the 5 equals 32. Yeah.
Okay.
So,
I see how you do it.
So 2 to the 3 equals 8. So that's one answer. We already wrote that down. And then the other one was 2 raised to the 9th. And that equals 512.
Oh.
So one of them was 8, one of them was 512. And I think the answer said one of them was 3 times the other. Like, can you read the first answer or the answers?
I switched. Well, I shared. I don't know if you want to. Oh,
no. Just read them.
The answer is 3 times Jerry's original answer. So if the original answer was 8 times 3, it would not amount to.
Right, one amount to 512. So that's not right.
So the correct answer is 6 times Jerry's original answer. And then the last, or the third one is 9 times the original answer. So that would be what, 8 times 9?
Yeah.
That would be 2. So, and then the last one is the correct answer is 64 times.
And it's probably works out. 8 times 64 is 512. Okay. So that just means they were trying to get you to, I guess, evaluate what that was, and then just see how much more it is, maybe?
Yeah.
Yeah.
So that one's it'll be C, right?
Yep.
How'd you get on the last one? You just did the whole, what was it 2 to the 9, right? You got okay. You got 5 to 11. Oh.
Yeah, 2, and then the XY button, and then 9, and then equals. Yeah. Right, Haley's work. Okay, this is important because it has a negative in there.
Yeah.
-2 to the 8th. There's parentheses around the -2. So that means -2 times -2 times -2 times -2, 8 times. Okay. Which statement best describes Haley's first error? How many times did she write it? 1, 2, 3, 4, 5, 6, 7, 8. Shoot, if she did it 8 times, she should get a positive number.
She should have, yeah. And okay, yeah. And this 256 is just negative.
Yeah, she used the wrong number over here. No. She used the wrong number. No.
So that's the last one. Okay.
She made a sign error. Yeah. Because if you did -2 times -2, that becomes a positive. Times the -2, that becomes a negative. Times another -2. And if you keep doing that, if you do it an even number of times, your answer should be positive. If you do it an odd number of times, your answer should be negative. All right, this is the fraction one.
So this is going to be one of those. Okay.
Yeah, try what you think.
So I got 27 over 1,000.
Yep. Okay, so it's saying do all of those and see which ones come out to the same as -1 over 64.
Oh, okay. That negative's for both, right?
Yeah, okay, so the negative in the middle.
I think we've done this one before, or like that type.
Yeah, okay, so negatives in the middle, they're kind of weird because there is a number on the top, like for the first answer, and that's 1. And there's a number on the bottom, and it's 4. And sometimes you can think of it as 1 divided by 4. Sometimes you think of it as 1/4. But if you had, so like 1/4, that's the same as 0.25, right?
Yeah.
So it's weird saying like the negative in the middle, like does it go to the top or does it go to the bottom? The answer is yes and no, like kind of whichever one you want to do. It's like asking, so -25, does the negative go to the 2 or does it go to the 5? But it just
Okay.
goes to the 25.
Yeah.
So really the negative goes to the 1/4, but like procedurally when you actually work out stuff, yeah, you can put it in the top or the bottom. I think all of these answers just put it in the middle, which means you kind of just have to know the rules for exponents. Yeah, like when you multiply an odd number of negatives together, you get a negative, and when you multiply an even number of negatives, this one's there's a lot going on this one. Pick ones that you think would work, and then I'll explain afterwards because there's only this one and the next one. Yeah, there's a lot going on this.
The first two are exactly the same, right? Just because the negative's outside the parentheses, does that mean anything?
So because the exponent is 3 and 3 is an odd number, when you can move like the negative on the inside or the outside means the same thing. If it was an even number, it would be different. So like the next two answers, those are different answers. The first two answers are the same answers. And it's because the exponent is odd on the first two and the exponent is even on the second two. Here, let me write these answers down and then I'll share and explain. Okay, check all that applies. So it doesn't even tell you how many. All right, I'm going to share.
All right.
Okay, so I think these are all the answers. One where there's a negative on the inside, one and a negative on the outside, and that goes for each single one. It's negative inside, negative outside. Here's the thing to remember. Like the way we did this little thing, if you're multiplying and, what was it? Like plus, minus, minus. Yeah, so like if you do a positive times a positive, you end up with a positive. So that's like no big deal. That's just normal. If you do a positive times a negative, you end up with a negative. If you do a negative times a negative, you end up with a positive. That's the whole idea behind this. And the way like you can write it out is like plus times plus equals a negative plus time. Oh, sorry, no. What am I thinking? Negative times negative equals a positive. Negative times negative times negative. What does that equal? So here's the idea. Negative times a negative is a positive. That's the whole thing. Negative times negative is a positive.
So it becomes positive.
Yeah. And so here, negative times negative is a positive. So then if I write down the rest, I would just have, like after I simplified the first part, the rest would be a positive times a negative. Well, positive times a negative equals a negative. So here, that equals negative. So that means that equals negative. So when I multiply a negative 2 times together, this is 2 times, I get a positive. If I do it 3 times, which is the case here, negative times negative, that equaled a positive, times another negative, that equaled a negative, then I get a negative. If I do it 4 times, the idea is negative times a negative, that equals a positive, times a negative times a negative. Well, that's times a negative. If I bring that one down, that equals a negative because negative times a positive is a negative. So this one would be a negative, and then bring this one down. And we're back to the beginning. Negative times a negative is a positive. So If I do it 2 times, I get a positive. If I do it 3 times, I get a negative. If I do it 4 times, I get a positive. If you had to guess, when I do it 5 times, what will it be?
It'd be a negative. So pretty much even numbers would make it a positive.
Right, yeah. So here, this is why it doesn't matter. If I have a negative on the inside, yeah, I'm going to be writing down negative 1/4 times negative 1/4 times negative 1/4. That's the same situation as this. I don't even have to write down the negatives. I could just remember that, oh, that's odd, so I'm going to end up with a negative something. And then 1 times 1 times 1 is 1. And then 4 times 4 is 16. Times another 4 is 64. Like, I don't have to remember that there were negatives on each one because I knew that there were an odd number of them, so my answer has to be negative.
And when it's out, the parentheses, what does that mean?
When it's outside of the parentheses, that means you ignored it until the very end. So that's negative, and then 1, let's do it like this. 1/4 times 1/4 times 1/4. So you still do 1 times 1 times 1, which is 1. And 4 times 4 times 4, which is 64. And then put the negative on at the very end. So it still comes out to the same.
Oh, that's it. Okay.
When it's... So here's the different part. Here's the weird part of the rule. Because when you multiply 2 negatives together, you get a positive. So if the negative is on the inside of the parentheses, that means you're writing down negative 1/8 times negative 1/8. Well, a negative times a negative is a positive. So my answer here has to be a positive number. Has to be a positive. Negative times a negative is a positive. So then 1 times 1 is 1. 8 times 8 is 64. But my answer has to be positive because I have a negative times a negative. Negative times a negative. When it's on the outside of parentheses, you just leave it alone until the very end. So that would mean negative, and then 1/8 times 1/8. 1 times 1 is 1. 8 times 8 is 64. Leave it alone until the very end. So that would be negative 1/64. So actually, this one is like what the answer said, right? The answer said negative... Did it say negative 1/64?
Yeah, it's negative.
Yeah, so this one works. This one gives you a positive because the exponent is negative. All right, sorry, because the exponent is even.
Yeah.
Both of these give you... Both of these give you a negative because the exponent is odd. And then this one gives you a positive because the exponent is even. That means you'll do a negative times a negative, and then a negative times a negative, and then a negative times a negative. All those end up being positive anyway.
Yeah.
So this one will be positive, so we know that one doesn't work. This one will end up being negative. Just what will it be? That's like 1 to the 6th and 2 to the 6th. What's 2 to the 6th? Is that 64? I think it is.
Yeah, it's 64 for both of those two.
Okay. So then that one would work out. Because the negative is tacked on at the very end because it's not inside the parentheses. So after the fact, you put on the negative. So both the first and second, not the third. The fourth one would work, not the fifth, and the sixth one would work. So 1, 2.
How does the first one work? Because it's by 3, right? So it should become a negative, right?
Right. Doesn't it say?
Or I mean, it should become. Oh yeah, it is negative.
And it should be negative. Yeah.
Never mind.
Okay. If it's an odd exponent, it doesn't matter whether the negative's on the inside of the parentheses or on the outside. Your answer is going to be negative. If it's an even exponent, then it does matter whether your parentheses are on the inside or the outside. Because if the negative's on the inside of the parentheses with an even exponent, like the negative goes away. Otherwise, it stays. That's There's a lot going on in that one. We'll go back and do that one when we see it again.
Any of these 8s were them? It's had to be this one, right? If it was even, let me do it then. I think I added the 3 to it instead of.
Wait, did I do something different than 8?
No. I think when I did it, I don't know if I did the freaking because it's 64, but it's gonna be this one because that one's positive, right?
Yeah, the other one, the one with the negative on the inside of the parentheses will turn out to be positive. Yeah, so you're correct. And then, yeah, did I do it? Wait, can you scroll up?
Yeah.
Oh,
I think you did on mine. Huh?
Yeah, you got it. Yeah. Okay. So
this one I would just well, now that you showed me that trick, I can just see the it's going to be a positive, and it's going to be the bottom one, 15, 6, 25.
Here's the thing. This is the thing that gets everyone, and it sucks because it's simply notation. But I'm going to share it with you right now. Hold on. Because there are no parentheses on this one. And it sucks because it really is just like, do you know the rule or do you not know the rule? And that's really it. It's nothing to like figure out or like nothing. It feels tricky, but it's -5 to the 6th. Yeah.
Yep.
This is different than -5 to the 6th, and it's just if you've seen it before, that's the only way you would know. So here's the difference. This one is the same as if the negative was on the outside of the parentheses. Those are the same. So then what you were thinking of actually doesn't like apply, because if the negative's on the outside of the parentheses, it just stays there till the very end, and then it's just 5.
So it'd be the negative.
Yeah. 6 times. What is that? So all that means the same thing, which is confusing because this one means -5 times -5 times -5 times -5 times -5. And this one does mean, oh yeah, the negative's on the inside. So if the exponent is even, then yeah, you just end up with positive 15, whatever it was. I don't remember what it was.
Yeah.
Blah, 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 blah. But since this is the same as this, it means the negative's on the outside, which means you have to just tack it on to the very end, so it should end up as a -15,625 or whatever it is. Does that make sense?
Yeah, I got it.
So if you have like negative x to the 5th, the way that you should think of it is negative x to the 5th, where the negative's on the outside of parentheses. And it's not the same thing as negative x in parentheses and then to the
inside.
So that's the distinction. Unless you've seen it, like, and get used to it, then you would never know. So It's a tricky one.
A little tricky.
So yeah, that one would be the negative.
Correct one.
Cool.
I don't know if you have time for that one. If not, we can do another dance.
Oh well, let's see the. Let me see the topic.
Next week, give me some hints on this.
Zero and negative exponents. Okay. Yeah, let me say some things, and then we'll see after that. So it said negative and zero exponents. I'm going to start out with zero exponents. Zero exponents. So like what does that mean? All that means is, let's start out with the simple thing like 3 raised to the 0. All that means is it equals 1. Like that's, you can think of it as the rule. Like you think 3 squared, that's equal to 3 times 3, so that's equal to 9. None of that matters when you have a 0 exponent. The rule is if you have something to the 0, that equals 1. So I'm going to write out a couple different ways we could have this. So like 3 over 5 to the 0. All of it is raised to the 0 exponent. So that means still 1. 3 to the 0 divided by 5, that's different. That means this part, the top part, is 1. So let me write it differently. So 3 to the 0, that's a tiny bit different. That just means the top part is 1, and the rest of it is just whatever it is. Let's say we have negative 10 in parentheses to the 0. Still just 1. Same rule applies. But what we just...
It doesn't equal minus 10.
No, only if we have that same thing that happened in that last question. If we have a negative on the outside, this one would be 1 and then the negative, so negative 1.
Okay.
And then that means the same thing for like negative 10 because these...
It's the same thing, right?
Yeah, same. So this would be negative 1. Sorry, if it was like that. Because it means the 0 is like attached to the 10 first, and then the negative, it doesn't even know about the negative, so it, like you keep the negative on. Here, the 0 is attached to the parentheses, and then whatever's inside the parentheses just gets dealt with the 0. So 10 to the 0 would be 1, and then same idea. So that's pretty much the whole idea for 0 exponents. I'm trying to think of like a weird situation. I guess another thing could be if you have like 3 to the 5 to the 0, that means the same thing as 3 over 1, which is the same thing as 3. I think those are all the situations for 0 exponents. Negative exponents. This is a kind of it's kind of a tricky one. If you have like 3 to the negative 1, that's the same thing as writing down, let's say, you can always put it over 1, right? Any whole number. even like with exponents or not, you can always put it over 1. Whenever you have a negative exponent, that's like, oh, take the whole thing with the base and then put it underneath. So that's actually the same thing as, this is a weird one, 1 over 3 to the positive 1. The negative exponent just means take all of this, move it to the other side, whether it's on top or bottom, and then change the exponent to a positive or whatever it was. So like, I'm just going to write down like a couple of things. If I had 5 to the negative 2 over 1, that's the same thing as 1 over 5 to the positive 2.
Okay. So it just switches.
Yeah, if it's negative on the top, you can switch it to the bottom, but then you have to change the sign. Which also means if you have 1 over 5 to the negative 2, that's the same thing as 5 to the positive 2 over 1. The tricky part is when this is not a 1. Just because it's confusing. But let me try and write down some stuff. 3 over 2 to the negative 2. We already know on the bottom, actually for any number, I could multiply the top by 1. It doesn't change anything, right? 1 times 3 is still just regular 3.
Yeah.
So if I did just in the top 1 times 3, that doesn't actually change anything. Same with the bottom. I could do 1 times 2 to the negative 2. That doesn't change anything. The thing that I want to point out, though, is, like, say we write that down. If we're using this negative exponent to move the base also to the top and then changing the exponent, we would write this 3, the 1 stays on the bottom, this all moves to the top. With a positive exponent, you got to change the sign, and then you just write the multiplication there. So like this thing moves to the top and just changes the sign of the exponent. And it works the other way around as well. So if you have like 3 to the negative 2 over 2, you would take all of this and move it down to the bottom. So that would be 2 times 3 to the positive 2. And then you think like, okay, what's in the top? Well, you can always write 1 times whatever this is. So then it would just be a 1 because that's what's left over.
Okay.
I mean, it's a lot. There's a lot going on.
Yeah. I'll watch video for this.
Yeah. The negatives, if they're negative on the bottom, you can move them to the top and make it positive. But even, like, you can go backwards as well. Like 3 to the second over 5. That's the same thing as, because you can always do times 1. So 1 over 5 times 3 to the negative 2. As long as, if I'm moving this to the other side, to the bottom or to the top, I have to change the sign of the exponent and make it negative.
And then how do you solve that? That's it, it's solved?
It's not, like, on these ones, I feel like they're not going to be solving anything. You're just going to be, I guess, like, they would write down, actually, no, they might write something like this. 3 divided by 5 to the negative 2. What does that equal? Well, first thing that you can think of is, wait a minute, this has a negative exponent. I can bring that to the top. So then you might go 3, and you can always write times 1, so that means there's a 1 in the bottom. And then 5 to the positive 2. So then that's the same thing as 3 times 5 to the positive 2. Well, that just means 3 times 5 times 5 because you're writing 5 2 times. So is that 25 times 3 is 75, I think. So that they might do something like that.
Awesome.
Or they might do like 3 times 2 to the negative 2 over 4 to the negative 1. In which case, this stuff would move to the bottom, this stuff would move to the top, the 3 would stay, so 3, whoops, 3, and then 4 to the positive 1, which just means 4, because that's moving to the top. And then 2 to the negative 2, that would be 2 to the positive 2 in the bottom. And then you just do the top on its own, 12, and the bottom on its own. 2 to the 2 is 4. And then just 12 divided by 4 is 3. So maybe they would have you simplify it like that.
Okay.
But there's a lot going on there.
Right.
I don't know. I'm gonna take a screenshot of this and then just text it to you. But otherwise, good luck. Would you?
I'll watch the video too, just to try to see what type of different ways.
Yeah, there's a lot. There's gonna be a lot. I feel like unless they do it like step by step, which would be nice. But I don't know. Would you be able to do tomorrow or? No.
I don't know about tomorrow. What about Saturday? If you're busy Saturday, don't worry. We could just do it again Monday or Sunday.
I could do Sunday night because Saturday, Christine and I are gonna go up.
Yeah, that's fine. Don't worry about it. Yeah, for sure. We can do Sunday.
All right.
I'll send you because I got paid today, so I'll send you a payment fee.
Okay, cool. Thank you.
I think we did like 5 sessions, right?
Yeah.
I think. I don't know.
No, that's fine. Whatever you think is good.
Oh, don't worry about it. Thank you, man.
All right,
yeah,
man.
for sure. Well, if Sunday, if not, if you're too tired, we just start Monday again.
Okay, I'll text you on Sunday then.
All right, man. Have a good night.
You too.
Good weekend too.
All right.
Peace.